Hello, my name is Morgan Sandercock and I'm one of the pilots on the Perlan Project. Today I'd like to tell you a little bit about Reynolds numbers. Reynolds number is one of the fundamental characteristics of aerodynamics, which is very important to aerodynamic designers. In fact, often more important than the number you may have heard of, the Mach number. Mach number, everyone knows, is a relationship to the speed of sound. Less than Mach 1 is less than the speed of sound. Greater than Mach 1 is faster than the speed of sound. But the Reynolds number is an entirely different quantity. It relates to the size of the airplane and the viscosity of the air it's travelling through. So for different size of aircraft travelling at different speeds, we have different Reynolds numbers, which fundamentally affects the way that the airflow flows over the airframe. So looking at a little tiny model like this is a model of a Boeing 747, and we could probably go to Boeing and find out from them exactly what shape this airfoil is. This airfoil is one of the most efficient airfoils ever built in the world. You know, it's flying around the world. Thousands of these are airborne right at this very moment. But if we took this little tiny plane here with that wonderfully efficient Boeing airfoil on it and threw it, everyone knows what's going to happen. This is just going to fall. The airflow doesn't flow over this little tiny wing in the same way that it flows over the full-size 747 wing. And that's what we're dealing with in the Perlan project. We're not changing our size so much, but we're changing the air that we're flying through. We're flying at such a high altitude that we're flying through very, very thin air. And that thin air, to us, feels like the same as air feels to this small model here. Maybe not quite this small. The Perlan is actually more like about a 1 metre wingspan model. And so we have to design an airfoil which would fly quite nicely on this little model and fit it to a full-size airplane that carries 2 people. So that's one of the aerodynamic and scientific engineering challenges that we're overcoming in the Perlan project.